So I'm gonna begin now. So for this afternoon or this evening, the aim is to go through as many papers as we can. I have from 2019 to 2023, and I also have a textbook open with me. No, and this textbook is a multiple choice textbook based on past papers. Now I'm going to start with 2019. It says it's 1 hour and 50 minutes. So I want to see, I'm going to try to see how quickly I can do it and also explain to the best of my ability all the answers. Alright, so number one says which of the following processes provide evidence of the particulate nature of matter? Let me open my pen. So the one that provides evidence on the particulate nature of matter, we know that diffusion that provides evidence. Diffusion provides evidence. The pen doesn't work. Yes, diffusion and osmosis. My laptop just froze. So yes, it's diffusion and osmosis. So it's I and I. Let me hope this is working. So the correct answer would have been B. Whenever I use the pen, my screen freezes. Or something goes wrong. What is happening? What is this? Let me reload. Alright, that is much better. Yes. Alright, number two. Which of these elements forms a chloride that is ionic in nature? I think we did something like this similar before. Ionic compounds tend to have really high melting points and boiling points. So I'm of course gonna go with the third option. The others would possibly be simple molecular crystals which have lower melting points. Due to their weak intermolecular forces. So for ionic crystals, because you have two ions, two oppositely charged ions being attracted to each other, that's a very strong attraction. So it's going to require a lot of heat to either melt or boil that substance to separate the strong electrostatic force of attraction. Number three, the arrangement of electrons in atoms of X and Y are 285 and 286 respectively. Which of the following options are true? Now, from the get-go, both have 3 shells. However, this one element X is in group 5, which means that it's a non-metal. Remember that from 5 to 8 are non-metals and 1 to 3 are metals, while group 4 is semi-metals. Right, so 5 is a non-metal, group 6 is a non-metal. Remember that the last number tells the valence shell, it also tells the number of the group number. Right, so both are non-metals, and therefore my correct answer would be B. Number 4, which of the following best describes the formation of a metallic bond? A metallic bond is formed when, definitely not anions. We already know that metallic bond is formed between cations and delocalized electrons. So I'm just going to look for that option. It's not anions. Metal atoms are held together by molecular forces. No, molecular suggests that it's a covalent compound, right? It cannot be metallic bond. C says cations are held together by a sea of mobile electrons. This one looks correct so far. D says positive metal ions are held together by a sea of anions. This right here is wrong, right? The only negative charges in a metallic bond is the electron. So you have positively charged cations and negatively charged electrons in a metallic bond. Therefore, My correct answer is C. 4 is C. Cations are held together by a sea of mobile electrons. Number 5. Which of the following elements does not form simple ions by gaining or losing electrons? Not form. Carbon. Carbon is in group 4. We know that you guys did organic chemistry. We know that carbon doesn't lose nor gain. It actually shares electrons. Yes, that's all it does. It shares. There is no point in time that carbon will just completely accept electrons or lose. It just shares. Copper is a metal. We know that copper is able to lose electrons. Calcium metal is able to lose electrons to form cations, and then chlorine, it's able to accept electrons. Yes, it can share, but it can also accept electrons to form its ion. So the correct answer here is 5A, which is carbon. Number 6, an element X has 8 electrons in its outer shell. Which of the following are possible isotopes of element X? And this goes back into the definition of isotopes, which says that isotopes have the same proton number but different neutrons. Right, and note that P is always equal to E if it's not an ion, which I mean protons and electrons are equal if it is an atom and if it's not an ion. So isotopes have the same proton number but different neutrons. Right, so let us look and see if we can find something similar. So in this case, note that we have the same number of protons in this case for A, same number of electrons. Yes, so we're confirming that they're the same atoms. However, the neutron numbers are different. So far I'm going to go with A. See, now we have two different number of protons. The fact that we have two different number of protons suggests that it's two different atoms. So this one could have been oxygen, and this one could have been, I believe, nitrogen, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Would have been fluorine actually, right? So the proton number gives you a lot of information about the atom. Proton number tells you the atomic number because it never changes. So in this case, notice that we have two different proton numbers, which means that it's two different atoms. So these are not isotopes of each other. For this one, when we look at it, we have 9 and 9 here. We have the same proton number and different neutron number. However, when we look at the electrons, as we can see here, so this part is correct. But for the electron section, it is not similar. Neither of the electrons are similar to the proton number. So one of them could have been 8, one of them could have been 9. But we're not seeing that in this case, right? So this one is wrong. Remember that for isotopes, they have the same proton number but different neutron number, and you have to also consider the amount of electrons that are present. Then for D now, this one, proton numbers are way too far, right? These are two completely different atoms, right? So let me just do a quick recap. The atomic number, which tells you what atom it is. So we know that we have hydrogen having an atomic number of 1. Then you have helium being 2, lithium being 3, etc. Right? So the atomic number gives us a wide variety of information about a particular atom. Not only that, it tells us about the proton numbers. Right? Yes, is someone saying something? Okay, so the atomic number, it tells us the number of protons present in an atom. Sometimes it tells us about the electron number. However, if the atom would have lost an electron, the electron number changes. That is why I am saying that not all the time you're going to have atomic number equal proton number equal electron number. These two are always equal on the other hand, atomic number and proton number. Alright, number 7, mass number is the number of, so mass number is usually the largest number. It tells you the mass of the nucleus itself. It is, let me see if I can.
Marcel, mute your mic.
Yes, please. I'm not able to mute the mic on my end. So mass number is the number of, as I said, the mass number is the mass. It's the weight of the atom. It's what carries the weight of the atom. And oftentimes the mass of the atom is accounted for based on the nucleus, the mass of the nucleus. And we already know that the nucleus contains protons and neutrons, right? So our answer that we're looking for should have protons and neutrons. Let me say this again. The mass of the atom is mainly accounted for by the nucleus, which contains protons and neutrons, not the electrons. We already know that the electrons are very small. Their weight is like 1 over 1840. They have a negligible mass. They don't contribute to the mass of the atom. It's the protons and the neutrons that contribute to the mass of the atom. So I'm going to look for that in this answer. Not neutron minus proton, not electron plus neutron, neutron plus proton. Yes, this is my answer. P plus N. Number 8, the mass of 1 mole of atom of an element refers to
B.
yes, Avogadro's number. Remember that 1 mole is always equal to Avogadro's number, which is 6.0 times 10 to the 23rd atoms, or number of particles. Yes, that's correct. Number 9, some calcium carbonate was reacted with the excess dilute hydrochloric acid. The volume of carbon dioxide evolved was recorded and plotted against time. So we're looking for a graph that shows an increase in the carbon dioxide gas as time progresses. Which of the following graphs represent this reaction? Which one is correct?
A.
A is correct, yes. Right, as you remember that initially it starts off very quickly. This part is very fast, and then as time progresses, when we're using up all our reactants, right, and we have less and less reactants, the number of carbon dioxide gas that we produce becomes the rate slows down, hence this line right here. Right, it's not a straight line. It can't be a straight line. It has to be a curve. This curve shows that the gas is increasing, but at the same time the rate is decreasing. So 9 is A. Number 10, which of the following particles represents an anion? Okay, so I would choose to look at this from the amount of electrons perspective, because the number of electrons can always tell you, the electrons and protons can always tell you whether it's an ion or not. Note that in this case, these two have the same number of protons and electrons, right? Which means that it wouldn't have lost any electrons nor gained any electrons. So this is not an ion. This one, same number of protons, same number of electrons. It wouldn't have lost or gained electrons. This one, no. This one would have gained, oh, it wouldn't have gained any. It's the same, 8 and 8. But we're looking at this one. Note that it would have gained 2 electrons, right? Because for atomic structures, whenever we do our atom, we always have the same number of protons and electrons. But once it's the ion, we either gain electrons or lose electrons. And in this case, as we can see, we would have gained 2 electrons. So it's 16 plus 2, which would give us 18. And if we were to even write out the electronic configuration of this one, it's going to be 2, 8, 8. I really don't like this question though, because I would go with Y. Sasha Lee, do you know the answer?
I'm not sure,
I'm
but I
not
was
sure, but
gonna
I
go
was
with
gonna
Y.
go with Y.
Yeah, I'm gonna go with Y. However, elements in group A do not form anions. That is why I'm a bit peculiar. Elements in group 8 don't form anions because they already have a full valence shell. They don't have any reason to actually lose or gain anything. So I'm just gonna double check this one to make sure this is alright. Alright, so yes, it's fine. Number 10, D is the correct answer. Yes, it is. So our reasoning is correct. Alright, number 11 to 12 refer to the following types of substances. We have alkalis, which are soluble bases in water. We have bases, which are proton acceptors, salts, which are metals, a combination of metals and non-metals, and then we have acids, which are proton donors. Which of the following substances above can be described as an oxide of a metal? Oxides of metals are bases, and if you're ever confused, just think of a random metal. I'm gonna go with Na and oxygen. When you look at this oxide here, it looks very closely to sodium hydroxide, which is NaOH, right? And in actuality, if you were to dissolve sodium oxide in water, it would in fact form sodium hydroxide, right? So if you're ever confused or you're not sure, just think of elements that you know to be sure and you make your observations. As I'm saying, metal oxides, they are bases. So the correct answer is B. Number 12, which of the substances above supplies protons as the only positive ions in aqueous solution? Acids. Number 13, which of the following substance statements is true of endothermic reaction? Heat is given up to the surroundings. Actually, endothermic heat is absorbed, right, which is B. Heat is absorbed from the surrounding, hence it feels cold. 14. The mass concentration of potassium chloride solution is 60 gram per dm cube. What is the mass of potassium chloride in 25 centimeters cube of this solution? Alright, so the equation is, note that you can use the unit to tell you what the equation is. So mass concentration, let me see if I can type it. Mass concentration equal mass. See it here? Mass, and the negative right here suggesting that it's being divided. Mass over volume in dm cube. Alright, so we need to find the mass of potassium chloride. So we're just gonna simply transpose the equation. It's gonna become mass is equal to get rid of volume, we're going to multiply. So it's going to be mass is equal to mass concentration times volume, right? And the mass concentration that we have is 60 grams per dm cube multiplied by volume. As I say, it's volume in dm cube, so 25 centimeters cube to dm cube is going to be 0.025 dm cubed. And when I work this out, I get 1.5 grams. So C is my correct answer. Number 15, when solid lead nitrate is heated, it decomposes, giving off nitrogen, 4 oxide, and oxygen. The balance equation for this reaction is, we got this already.
It's A.
It's A. All right. 2 lead, 4 lead. Actually, let me just check the oxygens so I can get this done quickly. 2 times 3 is 6, times 2 is 12 oxygens on this side. 2 oxygen here plus 8 oxygen here plus 2 oxygen here, which is 12, right? A is the correct answer. Number 16 refers to the following information. Which two elements above, when combined, form mainly ionic compounds? Remember, the ionic compounds are formed between metals and non-metals. So I'm just gonna look at it and identify which ones. So an element in group 1. Oh, it's not in group 1. It is. Let me look at the atomic number. So the electronic configuration for this one is just simply gonna be 2, 1, which means it's in group 1 and it's a metal. So this element is a metal here. This one has 6 electrons, so it's gonna be 2, 4. Elements in group 4 tend to share electrons only. They don't form ions. So this is gonna be a metalloid. Just gonna put an X right here. For the one with 17, its electronic configuration is gonna be 2, 8, 7. The fact that it's in group 7 makes it a non-metal. So this is a non-metal. And then group 18 now, it's gonna be 2, 8, 8. Which, although it's a non-metal, it's unlikely to form a bond because it already has a full outer shell, right? So therefore, element I and element III, which is a metal and a non-metal, will combine to form ionic compounds. The correct answer is gonna be B. Number 17, which of the following mixtures can be referred to as a standard solution? Iodine in 50 centimeters cube of ethanol, 30 grams of sodium chloride in water, sodium chloride in 50 grams of water, 30 grams of iodine in 50 centimeters cube of ethanol. Now, a standard solution is a solution that has known, you know what substance is present, and you know either its mass and its volume. So it's a standard. It has everything that is known. You know something about it. You know a volume. You know some digits, volume, mass, concentration. You know something about it. Now in A, notice that they gave us iodine, but they didn't see it here. They didn't tell us anything about the iodine. They just say it's iodine, right? But they didn't say what mass or what volume of iodine is present in the ethanol. In B, they tell us about the sodium chloride, yes, but how much water is there? Right? We need to know both. We need to know some information about both of these substances in order for it to be a standard solution. C, sodium chloride in 50 centimeters cube of water. No, this is wrong. We don't know anything about the sodium chloride. And D, now notice it gives us 30 grams of iodine and 50 centimeters cube of ethanol. Right? We know everything that we need to know. So 17 is D. And this can actually lead us into knowing the mass concentration of the iodine. Why I said that? Because we know the mass and we know the volume, which can lead us into mass concentration calculations. Items 18 to 19 refer to the following terms: ionic crystal, supermolecular, macromolecular, and metallic. In answering items 18 to 19, each term may be used once, more than once, or not at all. Which of the following terms above describe the structure of sodium chloride? Sodium chloride is an ionic substance, therefore it's going to be an ionic crystal. Sodium is a metal, chlorine is a non-metal, ionic. Right? Which of the terms above describes the structure of copper? Copper is a metal. It has to be metallic. 20. Which of the following oxides react with both acids and bases? Now, we call these types of oxides amphoteric oxides, and they're usually ZAP, which is zinc oxide or zinc hydroxide, aluminum oxide or aluminum hydroxide, lead oxide or lead hydroxide. That's what P means, sorry. So the correct answer is C. Amphoteric oxides react as acids and bases. Right, aluminum oxide is one of those. Magnesium oxide would have been a basic oxide. It's a metal oxide, hence basic oxide. Copper oxide is also a basic oxide, and calcium oxide, basic oxide. Number 21, the equation for the reaction of silicon with chlorine is this: silicon solid plus chlorine gas to give silicon tetrachloride. In the reaction, silicon is the reducing agent and is, let me just put in, I'm going to put in some oxidation states so I can make the deduction a little bit easier. So solids, we know that they have an oxidation state of 0. Gases also have an oxidation state of 0. Liquid usually have an oxidation state of 0, but I'm going to see what's going on. Silicon is in group 4. It usually doesn't share nor lose, but in this case, it has a 4 plus charge. I'm going to say that silicon is being oxidized. Its oxidation state is increasing. Yes, this one right here. It goes from 0 to plus 4. If it were the chlorine, it's gonna be chlorine is being reduced because its oxidation state is decreasing. It goes from 0 to -1. Number 22 refers to 1 mole of each of the following acids. So we have sulfuric acid, ethanoic acid, and this looks like, is this methanoic acid or dimethanoic acid? Okay. Which of the acids above would require more than 1 mole of sodium hydroxide for complete neutralization? I'm gonna go with this one and this. Alright, and you can actually do the reaction. What they mean by more than 1 mole is basically the coefficients that you would need to balance the equation. So if you were to do the reaction, how I knew what to do was, in fact, I looked at the amount of hydrogens that would react. In this case, we have 2 hydrogens, 2 reactive hydrogens, which will tell us that we're going to need 2 mole of the base to react. Also, for this one, we have 2 reactive hydrogens, hence 2 mole of the base. And in this one, we only have 1 reactive hydrogen in ethanoic acid, hence 1 mole of the sodium hydroxide. Right? If you were to do the equation, which I'm gonna do now so you can actually see. I'm just gonna do the first and second one. So sulfuric acid, which is H2SO4 plus NaOH, reacts to give Na2SO4 plus water. If I were to balance this, I would have to put a 2 here because we already have 2 sodiums here. And I would also have to put a 2 here to make us have the same number of hydrogens. Right? So you can therefore see that for every 1 mole of sulfuric acid, you need 2 moles of sodium hydroxide to neutralize that sulfuric acid. Right? For the ethanoic acid now, which is CH3COOH plus NaOH, note that for carboxylic acids, the reactive hydrogen is only this hydrogen in the carboxylic group, in the functional group. So it's gonna get displaced by the metal and it becomes CH3COONA plus water. Right? Note that it was one hydrogen here and it's being replaced by one sodium. This equation is balanced as it is, right? So we can therefore say that for every 1 mole of ethanoic acid that is involved, 1 mole of sodium hydroxide is used to neutralize it, right? And it would be the same here. This reaction would look very similar to the first one. So I'm gonna go with my answer to be uh I, yes, that one right there. As I say, how I simply did it was to just look at the amount of hydrogens that are able to be replaced. In sulfuric acid, it's 2 hydrogens that needs to be replaced. Hence, it's going to need 2 mole of sodium hydroxide. In ethanoic acid, it's 1 hydrogen that needs to be replaced. Hence, it's going to need 1 mole of sodium hydroxide. And in the methanoic acid, I think it's methanoic acid. It has 2 hydrogens and it's gonna require 2 sodium hydroxides to replace that hydrogen. Number 23, the atomic number of an element is defined as the number of protons. Not protons and electrons, but the number of protons. As I would have said earlier, the electron number, yes, in an atom, the electron number, proton number, and atomic number are equal, but if it's an ion, then you know that the electron number changes based on whether that atom chooses to lose or gain electrons. I am currently at 24. Which of the following diagrams best illustrate the course of an exothermic reaction? For exothermic reaction, heat is being lost to the environment. Therefore, the reactants are going to have a higher energy than the products. Once again, for exo, heat is being lost to the environment, right? So you start off with a high energy, and once the environment gains that energy, once it's lost to the environment, the products that are formed have a lower energy or enthalpy, right? So A is exothermic. B would have been endo. Because in endothermic reactions, we have the substance actually gaining energy from the environment, gaining heat from the environment. So the products would have more energy than the reactants. 25. Which of the following statements is true for the equation below? Magnesium plus sulfuric acid gives magnesium sulfate plus hydrogen. Alright, so I'm just going to fill in my oxidation states. Magnesium in the solid form has a oxidation state of 0. AQ, so hydrogen would have been +1. Sulfate is 2 minus. It's the charge. Magnesium is 2 plus since it's aqueous. Sulfate is 2 minus. Hydrogen, it's a gas, so it's gonna be 0. So this says hydrogen is oxidized from 0 to +1. That is incorrect. Note that hydrogen was actually reduced. Reduction is the decrease in oxidation state. So it goes from +1 to 0. Hydrogen was actually reduced. This case says hydrogen is reduced from +2 to 0. That is wrong. It was reduced from +1 to 0. Magnesium is oxidized from 0 to +2. Yes, that is correct. Yes, this one is correct here. Oxidation means an increase in oxidation number. Yes, this one is correct. Magnesium is reduced from +2 to 0. That's wrong. Right, so 25 is C. 26. Which of the following factors will usually increase the rate of a catalytic decomposition of hydrogen peroxide? Increase the rate. Applying greater external pressure using a large volume of hydrogen peroxide. No. Using catalyst in lumps rather than in powdered form. No. Increasing the temperature. I think this is the only valid one. It's the first time I'm seeing this question. So the following factors will usually increase the rate of catalytic decomposition of hydrogen peroxide. So you already add the catalyst. It's decomposition, so it's being exposed to temperature. And if you want to increase the rate of something, you simply increase the temperature. Pressure does affect the rate of a reaction, but it only affects the reaction for gases. So I'm gonna stick to A being my answer. Number 27, in which of the following substances does hydrogen have a
B.
what's the answer? B?
B.
B. Alright, so in which of the following substances does hydrogen have a negative oxidation number? What's the rule? You know, you told me the rule last time, the same exact question. Hydrogen always has a positive
Um,
oxidation number, except when it's bonded to metals. Yes. Alright, D is the correct answer. 28. In the electrolysis of aqueous copper 2 sulfate solution using copper electrodes, the anode. What? In the electrolysis of aqueous copper 2 sulfate, okay, using copper electrodes, the anode, and we know that anode is negative, anode will accept the positively charged. Here I am. Anode will accept the negatively charged anions. These negatively charged anions are gonna be OH.
yes, that answer looks like C.
It does look like C because it's the cation that we expect to change mass. The cation is the one that would decrease its mass as it's losing copper. But the anode now, in this case, which is positively charged, it's simply just gonna gain, you're just gonna see oxygen bubbles coming off because you're gonna have hydroxide being displaced here along with sulfate. All you're gonna see some oxygen gas. So I think C is the correct answer. I remember that oxidation occurs at the anode. So yes, it has to be C. 29. Which of the following energy changes occurs during the breaking of a chemical bond?
A.
Energy is released when you break a chemical bond. Are you sure? You use energy to break a chemical bond. You release energy when you form new bonds. Right? So B is the correct answer.
Oh,
Yes. Right. It doesn't have to necessarily be exothermic. There is no energy change. Right? So B is the correct answer. Glucose is converted to starch or cellulose by condensation polymerization. Remember that the only one that does addition polymerization is the alkenes. 31. Which of the following halogens is a liquid at room temperature? So you have fluorine, chlorine, bromine.
bromine. Miss, I wish all these questions come back,
Easy.
Yeah.
Okay. So fluorine, chlorine, bromine. We know that fluorine is a gas, chlorine is a gas, bromine liquid. They always repeat because we saw these the last time. I hope they don't change the paper though, because they have them time when them choose to change up everything. 32. Which of the following reactions occurs between propene and bromine? Propene is an alkene. Same exact question. Propene is an alkene, right? It's gonna undergo addition reaction. Bromine is gonna simply be added to the propene. 33. Ammonia may be produced in the laboratory by heating a mixture of ammonium chloride and
I'm not super sure. Calcium.
I don't think it is calcium chloride because you have the same anions. If it work, I feel like it's probably calcium hydroxide. Mm, calcium chloride from the hydroxide version. I think it's calcium hydroxide. I am going to check.
Because is it because it moved from NH3 to NH4?
So ammonia is NH3 and ammonium is NH4. We want to basically remove the ammonia from the chlorine itself. So we want some form of displacement reaction. Something that will definitely displace ammonia. And calcium is very reactive. It's one of those let's say tapa metals. It's very reactive in the electrochemical series. It's likely to displace the ammonia. So it's either calcium chloride or calcium hydroxide. Alright, so my first option was correct. I would have said B. That's the correct answer. I think if I did this paper, I would have gotten 60 flat. So what happens is that we have our ammonium chloride, we react it with calcium hydroxide. And remember how I said that this once you have the same ions in the reaction, it wouldn't really be a displacement reaction, right? Because you have chlorine and chlorine that not really do none. However, when you look at the calcium, as I say, it's quite reactive. It's in one of those, it's very high in the electrochemical series compared to ammonia. So I'm going to put the calcium hydroxide here. Right, so we have displacement. We're going to form calcium chloride salt. CaCl2. The OH is going to come off as water. And right, the OH is going to come off as water. And the ammonium is going to leave one of those hydrogens and it's going to come off as ammonia gas. Right, so as I said, the correct answer is B, calcium hydroxide, not calcium chloride, not the one with the same ion, but the calcium hydroxide, this one here. 34, the compound CH3, CH2, 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 OH is, so we have 1, 2, 3, 4, 4 carbons, 4 is bute. It is going to be 1 butanol. We want to give the OH the lowest possible number. So it's going to be on carbon number 1. Which of the following substances conducts an electrical current and remains chemically unchanged? Does anybody know? All right, remember that you have metallic substances that when we use them, they don't change chemically, but you have electrolytes, which whenever you use those in electrolysis processes, those electrolytes, they decompose, or they are chemically changed. Metals are not. All right, so in this case, our answer is gonna be D, as in dog. Copper. Copper would not change chemically at all, but if you were to put copper sulfate, you aqueous copper sulfate, and you pass an electric current through it, you're gonna have copper ions being placed on one of the electrodes. Likewise, for sodium chloride, you're gonna have sodium ions being placed on one of the electrodes, and you're gonna have chlorine gas being produced. That is essentially decomposition, right? And know that the question is asking us about something that does not change chemically once an electric current is passed through it. In this case, it is copper. 36 to 38 refers to the following metals. Which metal does not react with an acid to produce hydrogen gas? The correct answer is C. Copper is lower in the electrochemical series than hydrogen. The two metals that are lower than hydrogen, so it's hydrogen, then it is copper, then it is silver. I just remember these two right here. Silver being the lowest. I remember that you can't have a lower metal displacing something higher in the electrochemical series. So if you added copper to an acid, which is for example HCl, the copper would not displace the hydrogen in the acid, right? So the answer, oh my bad, I should bring it down here. 36 is C. 37. Which metal is covered with a passive layer of oxide? D, which is aluminum. Passive meaning that it's good, right? Know that all of these metals can have their oxide layers. So you can have sodium oxide, iron oxide, aluminum oxide, copper oxide. But passive meaning that the oxide layer is quite good and useful. Iron oxide is rusting. Iron oxide is red brown. It's the same brown rust that you see on nail. That is iron oxide, and it essentially damages the iron. Copper oxide, same thing. Looks very similar to the rusting of iron. I have not seen sodium oxide as a form of rusting. However, I think it's a white solid powder which doesn't really have any use to us. 38. Which metal reacts readily with water to produce a strong alkaline solution? Sodium. Strong alkaline solution. We know a strong base to be sodium hydroxide, and I'm gonna go with the sodium here. 39. Cracking is the process of breaking down large alkane molecules into smaller alkane and alkene molecules. I don't even have to read anything else. Yes, that is my answer. 40. Hexane has the formula C6H14. Which of the following statements is true about hexane? It is a hexane. That's an alkane. It's a covalent compound. Yes, it is. It is unsaturated. That is wrong. Hexane is actually saturated. It has all single bonds. It's an alkane. It belongs to a group of compounds known as alkanes. Yes, it does. So 40 is B, as in boy. 41. A chemistry student wishes to determine the presence of ethanol. Which of the following reagents will he need from the laboratory to accomplish this task? Ethanol, potassium dichromate, which is the breathalyzer test. Ethanol is alcohol. We use potassium dichromate to determine the presence of alcohol, where it changes from orange to green. 42. Which of the following gases is not considered to be toxic? Sulfur dioxide is Oof. All right. I think all of these are toxic. The most toxic being carbon monoxide. So I'm just gonna cross this out. Ah, carbon dioxide is it's a greenhouse gas. Will I say it is toxic? Essentially, do you know the answer for this one? I'm relying on you. So I know you would have probably gone through this paper already.
No, miss, I
No,
don't
miss,
know
I
this
don't
one.
know this one.
Alright.
I can't
I
get the
can't get the
answer.
answer.
Alright, let us go through. So it says sulfur dioxide. This gas is known to be harmful to the respiratory system and can cause irritation to the eyes, throat, and lungs. Yes, sulfur dioxide is toxic. Carbon dioxide, while high in concentrations, can displace oxygen in the air, in the lungs. It is not classified as carbon dioxide. This is the one I was actually gonna choose. Because even though we say it's toxic, technically it's not, because plants use it. It has some form of use. Um, yes, we cannot inhale carbon dioxide, and actually we're not supposed, so it can be converted to carbon monoxide, but as I say, plants use it, so it's not really considered to be toxic. While for nitrogen dioxide, it can cause respiratory illness. So sulfur dioxide pungent, I think that nitrogen dioxide also pungent, and carbon monoxide is very toxic. That's produced by cars. So I'm gonna go with 42 to be B as in boy, carbon dioxide. Try to remember this one. 43. Which of the following statements is true of soapless detergents? They are made from fats. Soapless detergents. They are made from fats. They are biodegradable. They are inorganic materials. They are not affected by hard water. What's a soapless detergent? So let me type it. You guys have done the saponification lab, I hope. Soapless
Yeah, I don't
detergent. I
remember
don't
it, miss.
remember it. Alright. So soapless detergents, these are synthetic detergents. They're not organic, while soapy detergents are. They're not made from fats, because fats would have been organic, so they're not made from fats and oils, and are synthesized. So a lot of soapless detergents are, remember I gave you guys the example to be like the detergents, the big heavy duty ones, those laundry soaps, those are soapless detergents. While soaps, no, soapy soaps are, for example, bar soaps that you use on your body. Those are really organic. Which are like the pear soap, those are soapy soaps. They're made from organic material and actual fats. Um, so which of the following statements is true? How do I get rid of this? Is true of soapless detergents. They are made of, I can't say anything. They are made from fats. That is wrong. They are biodegradable. That is wrong. Soapless detergents are not biodegradable. Know that they are made from synthetic materials, hence not biodegradable. They are inorganic. Yes. They are not affected by hard water. No. Matter of fact, they are affected by hard water. So the correct answer that I'm gonna go with here, I want to highlight this and come back. And I'm actually gonna type in my text.